Hi, I'm Brian Faith, VP of Sales and Marketing at QuickLogic. We're here in Las Vegas at CES 2013, and what I'd like to do is walk you through some of the things we're showing in our booth this year. First, I'd like to take you through some of our smart connectivity demos. Firstly here, this was our recently announced Texas Instruments AM335X catalog solution for camera interface. This board is sold by Circuit Co. with a 7-inch LCD and what they call a camera cape. The QuickLogic device is on the cape, and you have an image sensor here, 3.1 megapixel from Actina. This plugs into the main board on the back, and it enables a 3.1 megapixel camera to send that video data back to the AM335X processor. So as you can see, I'll pan this around. And you can see that it's giving wide VGA resolution at 30 frames a second. Our second reference design is what we call Jupiter. Jupiter is a USB form factor card. It has a QuickLogic Arctic Link 2 CX solution platform on here. And what this allows you to do is plug these cards into anything that has a USB host and read and write memory. In this case we have eMMC memory, but it could also have SD card memory in these sockets. It lets you measure performance, enable and disable the security features that we have built into the Arctic Link 2 CX. This last platform is what we call Orion. We've discussed this in the past. Orion is what we call an SDIO concentrator. In the QuickLogic device, we have an SD client that allows you to connect to an SD host. In this case, this is a Texas Instruments reference board. And then we have a lot of different I/O around the periphery that we can aggregate back up into an SDIO interface up into the processor. So SDIO concentrator, the board is Orion, and also shown here at CES. Okay, now we're going to talk about our visual and display solutions that we're showing here at CES. So this first demonstration is what we call BCC, or background color compensator. What this technology does is it alters the projected image to account for what you're actually projecting onto. In this case, you're projecting onto a white piece of paper, which is an ideal projection medium. And you can see that this says a forest scene with some snow. Now, if you're projecting against a different one, like say a green wall, you'll see that everything turns to a green hue. And what BCC will do is it'll actually compensate for that, and I'll change it right now, there. And what that actually did, it's very minor, and you may not be able to pick it up in the video so well, but it actually looks more like the realistic colors we had when we had the white background. And as you can see, I'll remove this now, and this projected back on the white wall has kind of a green hint to it. If we go back to the white, it actually cleans it up for the white image. So again, it compensates for the projected medium, and that's called BCC, background color compensator. Here we have some demonstrations of tablets and smartphones using the V and DPO technology. Some of you have already seen the Motorola Zoom and the Apple iPad hack. We've actually hacked into these products with the V technology so that you can see the impact both from a viewability point of view and also from battery life point of view. We also have two Pantech smartphones, both of which have the V technology. Here we can do a side-by-side demo so that you can see the benefits of the V technology, again, both from viewability and from battery life savings. Okay, also at our Pico projector theme table, we have a few different Pico projectors here to show you. Obviously this one is the one we've talked about in the past, the Micron Pop Video. That's here. The sort of second generation one from General Imaging called iPico. We have one of those here to show. And then we also have a Go Big, which is a product that's been announced by Platform Development, and we have one of those here as well. Okay, and the last demo we're going to show here is our Arctic Link 3 VX demo system. This is a tablet display, and we're driving this display from a PC. As you can see, this is a temple in Japan. Right now, the display and our device is consuming 3.1 watts roughly. Backlight is at 38%, V strength is at 13. And you can see the details in the woodwork. What I'm going to do is turn off V completely. You'll see that the screen appears to get very dark. That's the impact of V going away. You'll then see the backlight increase so you can get back some of the viewability that you lost. Here I'm turning it off. You can see it got quite dark. We lost the detail. Now the backlight is getting cranked up to compensate for that, back to 80%, V strength of 0, and the power is almost 4 watts. So you can see that we can save several hundred milliwatts of power, and you can improve the viewing experience with V and DPO.